Hello and welcome to the OpenAGS tutorial. Today we're going to be exploring an example analysis in order to show off the features of OpenAGS. So first we're going to go to the Create a New Project Here link. The rest of this homepage is just information about various formats that the program can accept and the like. So we're going to go to the Created Project link. We're going to give it a title, so just do demo for this one. Analysis type, we're going to do prompt gamma, but you can also do regular neutron activation analysis. So we're going to upload our spectrum files now. So let's just select these. All right, and we can also upload a standards file with locations of known peaks and sensitivities. However, for this run, you're just going to use the built-in standards file. All right, if you do neutron activation analysis, just a note, you will have to provide a standards file. So now we can create the project, and we go to this viewing screen here. So first of all, this is a graph of each file, counts per second versus energy. You can change the linear and log scales, as well as zooming into a particular region with the zoom tool. You can pan around, switch to the pan tool, pan around. You can also reset the axes with the auto scale button there. So you have a lot of nice graph utilities, and down here on this little selector, you can select which file you have. So this will go to file 3 or file 2, and you can go back one, you can go forward one, you can go back all the way or forward all the way. And so yeah, that's kind of your graphing utility. And then you can add and edit regions of interest. So let's add calcium 41 and boron 11. And so we're just searching them and clicking on them to add them to this list here. And if we added something we didn't want, like aluminum, we can always remove it from that list. And then submit these. Again, you can always edit them by going back here, changing things, and submitting again. Also, we've got settings for peak types and ROI widths and the like. Not going to change any of those right now, but you can, and you can at any point. Now we can select a region to zoom into if we want. So we have all of our ROIs conveniently here. And let's zoom into this one for calcium. And we notice a little bump in this file here. So let us just, we can also adjust the min energy and max energy to kind of isolate that a little bit. So we can set the min energy to like 4410 and the max energy to like 4430 and just get the peak in view. And now we can compare the region with a different file. So let's just compare it with example 1. We're looking at example 3 right now. We select our files, our range, and whether or not to overlay. So let's start by not overlaying and have a look there. So update the graph here. You can see both of these have the bump. If we change the file, still both have the bump. If we overlay them, we can see that they're a little different in amplitude, and that's just because of the different sample volumes used to generate these files. We can see that all the files are slightly different, which is why if you don't check overlay graphs, you can kind of get a more general view because it'll be scaled relative to their highest point. All right, so let's close out of that here. And the last thing you can do on this view page is you can download a spectrum file as a CSV file so you can more directly interact with the data if you would like. So we can just save that there. And now let's start the analysis. Okay, so here we have the boron peak fit, and first of all, I'm going to go ahead and change this to a log scale just so we can see the peaks easier. And okay, so we have the boron peak is the big one, and we have this little Gaussian here at 465, and we have something that it found that isn't really there at 489. So let's start by removing that from the fit. And other than that, the fit looks pretty good, so we're just going to go ahead and hit that reanalyze button, and you'll see now that peak is gone from the data. It's been redone. So this first calcium isotope here, this first calcium peak, my bad, is fitted just fine. It's the only thing in the region. Also, both of the boron and the calcium are automatically matched to the correct peak here. So there shouldn't be any concerns with that, though if you would like to change the match, you can. Alright, so now, okay, here is the third part, and here we're going to show off some of the other features. So we're going to add a peak because it missed this peak here at this little bump. So we'll do a Gaussian at 4424 or so, and with an amplitude of about 0.5. These are parameter estimates. They just help the fitter do its job better and more efficiently. So reanalyze, as you can see, it got perfectly fitted. If you can put in a wide range of estimates, and it'll still fit it very well. So there's that. And also, let's just say we want to edit the range a little bit, start at like 4410, because it's just kind of flat in this direction. So if we want to do that, then we can reanalyze it again, and you can see the range on the x-axis changes. All right, so now you can edit the range, you can add peaks, you can also edit the background once there are more background types. That will become an option to choose like a linear versus an arctan versus a quadratic background. All right, and this last region looks fine. Okay, so now that we're done fitting all of our peaks and they've all been automatically matched and we haven't had to change any of those matches, let's view the results, and we see a confirm button here. If you've matched all peaks and would like to proceed, please click submit. So we do. And now we get the view results pop up, and we view the results. And here we have them by each file. We can get CSVs of those. We can also look at them all tabulated. And from this page, we can then go back to the spectrum view. We can go back to the analysis, and generally, we can just continue to optimize this until we get good output data, and then we can get the Excel or the CSV out of it. All right, that concludes the tutorial of OpenAGS. Thank you for watching, and hope you enjoyed and enjoy using the app.